all right. Good evening and welcome to Environmental Coffee House. And Jennifer is back. Jennifer's
I am here.
back. We are thrilled. It's been a while, Jen. You have probably so much to talk about, so much to
Oh my
tell.
God, so much, so much.
So
Yeah.
much. So, what you been up to, kiddo?
Well, I had myself a journey to Alaska and I lived to tell the tale. And I even had an
Wow.
abrupt climate change experience event when I was there, completely unexpectedly. So I am so interested in the
Woo!
state of the glaciers all around the world. So we are taking a deep, deep dive into ice tonight, guys.
It
So
is. Well, I want to tell you, everybody, that tonight's topic is the Arctic, and I am not going to look at the chat. We have a lot to do. So if you want to ask questions or anything, make comments, put a Q in front of it or a super chat. We're going to do it at the end because we have a lot of stuff going on. So before we do have a breaking in kind of video, and but I didn't know if Jennifer wanted to talk a little bit more about where she's been, or
no,
you want to wait till we.
no. No, I don't want to.
All
I want to
right.
see the video.
All right, all right. We have a warm up for you guys. It's really going to give you the idea of the whole show.
It's
And
summertime,
up, okay.
but the living is
Hang
no
on, hang
longer.
on, hang on. Sorry about that. Okay, everybody, strap in and watch.
It's summertime, but the living is no longer easy. This has been a week of unprecedented heat. First, the European Union's Copernicus Climate Change Service declared Sunday, July 21st, as the hottest day on record. Then on Monday, July 22nd, the mercury climbed even higher. And now we have just received preliminary data indicating that Tuesday, July 23rd, was in the same range. In other words, this past Sunday, Monday, and Tuesday were the three hottest days on record. But let's face facts. Extreme temperatures are no longer a 1 day, 1 week, or 1 month phenomenon. If there is one thing that unites our divided world, is that we are all increasingly feeling the heat. Earth is becoming hotter and more dangerous for everyone, everywhere. Billions of people are facing an extreme heat epidemic, wilting under increasingly deadly heat waves, with temperatures topping 50 degrees Celsius around the world. That's 122 degrees Fahrenheit and halfway to boiling.
Probably everyone is aware that the Arctic climate is changing in profound ways, and including the following. We have warmer air temperatures, we have less ice, thinner ice, we have more frequent and stronger storms, melting permafrost, less snowfall, more rain, more river input, and warmer water from the south. So let's just go through a few of those quickly. So last summer was actually the hottest summer on record in the Arctic Ocean. And the plot you're looking at on the left is showing you the temperature difference from the long-term average in color. And as you can see, it's all red. So the Arctic is heating up, and some of these are as warm as 7 degrees Fahrenheit above the long-term average. And on the right here, this shows you a time record of that change. And you can see about 1980, it really started to heat up, and it's really just been steadily getting warmer and warmer as each year goes by. Now, in terms of ice, we first started measuring ice from satellites in the late 70s. And typically it's in September when you have your seasonal ice minimum. So in this plot here, the yellow line is showing you the median ice extent from 1980 to 2010. And then a little bit later, from 1990 to 2020, you see that it's moved further in. And now this is showing you what happened last summer. And you can see how much the ice is retreated. And that was only the sixth amount of extent of loss that we've had. So it's even worse than you're seeing on your screen here. And some models are predicting that, we will have ice-free conditions in the Arctic as soon as a few decades from now. All right, I told you that we had more frequent and stronger storms. Well, here's a really beautiful visual satellite image of an Arctic storm. So this is a low pressure system, and the air is circulating around like this. And these low pressure systems tend to propagate down in this direction, and then the strong winds come along the coast. So a few decades ago, we had a lot of shore-fast ice along the coast, and these storms really wouldn't make a difference. But now, with the lack of ice, these storms are resulting in a really strong storm surge and a lot of wave action, and that's causing massive erosion all along the coast, and that's a really big problem.
The second day in a row, record-setting heat out in Bethel, nearly 70 degrees in Nome, and seeing those mid-60s all the way to our northernmost point in Ukiyavik. Cooler.
The Juno Ice Field has lots of glaciers all joined together, and they all come together in the middle. And we found that the ice field is now shrinking 5 times faster than it was from 1948 to 1979. So it's the rate of shrinkage has really accelerated in the last 10 to 15 years. What's happening is that as the climate is changing, we're getting shorter winters and longer summers. We're having more melt, a longer melt season. And the elevation at which snow is staying all year round is rising. We already know that Alaska has one of the biggest ice volumes in all of the world's countries. And this ice volume, a lot of it is in these low slope ice fields. So even though some of them are higher than Juno, as our climate continues to warm, they too will pass this irreversible tipping point. And this is going to continue to accelerate the rate at which sea is rising, and that's quite important should you happen to live in a coastal city like Juno.
That was pretty intense.
Yeah. What a great composite you put together, Sandy. That's just amazing. Thank you.
Well, I hope everybody got something, because that really is what the show is about. So here we go. Jennifer, take it away. This is your this is your thing, baby.
All right, guys. I just came back from Alaska and I wanted to see the state of the glaciers. So I took kind of a glacier surveying trip. This is the Endicott Glacier, the Endicott Arm. I went with a girlfriend of mine and we had a fabulous time. That's Mary. She and I have been friends a really long time. Hi, Mary.
We'll drink to Mary.
And we had an amazing time. And we can move along here. One thing that I did that turned into a climate change kind of near catastrophe was I did this rafting trip. So that is the Mendenhall Glacier back there. And you can see it's pretty far receded at this point. Sandy had a little animation, but I took a rafting trip. This is
Look at
Mendenhall
that.
Lake. It used to be Mendenhall Glacier, but now it's Mendenhall Lake. And
Unreal.
this also becomes Mendenhall River. That river was about 30 feet wide, and now it's 150 feet wide and just crashing because it behind the Mendenhall Glacier is the Juno Ice Field, and it's like 1,500 square kilometers or square miles, actually. So
Mm-hmm.
pretty interesting. So this is the beginning of the rafting trip. We're just about to pitch across Mendenhall Lake and go down Mendenhall River. This is somebody's poor dock. Look at that dock up there. I took a picture of that. Basically, that used to extend out. You see all that debris up there? This is because there are these ice dams that are on the Mendenhall Glacier. And last summer, a couple of these ice dams failed, and there are giant ice lakes behind these ice dams. And so basically, it's like disgorging a huge amount of water, and it's causing flooding, and houses are falling into the river now and stuff like that. It's pretty amazing. And it's also causing like trees to go into the river because the banks are really eroding. So
I know.
let's continue on down. Oh, here we have a totem pole. I believe that's in,
Was that in
I think that might
Ketchikan
have,
or Juno?
it might have been in Ketchikan. Ketchikan has a lot of totem poles. They are like
Interesting.
the totem pole people. It's kind of amazing.
Yeah.
And this is in the Tungus National Forest, and it's so lush and beautiful. I almost felt drugged by the oxygen because, being from Colorado and our very low oxygen environment, and it's kind of scrubby, even though people seem to think Colorado's lush, it's not. This is lush. This is like something
Wow.
I had never seen, and it was like, oh my God, it's so wonderful.
Wow.
Yeah.
Wow. It's pretty cool. And then
Oh, a bear. Yes, this
looks.
is a black bear that was feasting on salmon. So it was
Oh
all the
boy.
environment's in really, really good shape there. Oh my God.
Oh,
Like
that's
nothing
good
I've
to
ever
hear,
seen.
Jen. He
Oh
looks
yeah.
he
No.
looks better than the one that was in my backyard.
Yeah. Yeah. Everything is in such good shape. I have never seen such a healthy environment as I did up there in Juneau and the Tongass National Forest. Just amazing.
That's great to hear. It's
Yeah. Yeah.
positive. It's
Yeah.
positive.
It's
And
positive.
there's the picture of the day. That's
Yeah.
behind we have it behind us
Yeah.
and you took it.
Yeah, I did. I took this. That's the Endicott arm of the Endicott
Look at the
Glacier.
veins going down there.
Yeah.
And then what? 50 years ago this was all covered.
Oh, yeah. No,
Eh,
I mean, if you just kind of go up where the gray is, right?
Mhm.
Like the rock,
Right.
like you can see there's no vegetation down there. The
Jeez.
glaciers have gone down quite a bit. Actually, just in case you guys wanted to know, the sea level rise on Earth, the greater part of it's coming from Alaska glacier melt because the heat is on in
Right.
Alaska and those ice fields are rapidly melting.
Which you saw in the video. And there you
Mhm.
are. Your little cute self. Okay.
Mhm.
So, here we are with a Zach
Yeah.
Labe, which is describing what's happening. And do you want to do this one, Jen?
Well, I think, Sandy, we are the sixth lowest ice extent on record. Am I correct about that right
Fifth
now? This
lowest,
is just ice extent.
fifth lowest on record,
Mhm.
2024.
Yeah.
And 1 square kilometer equals 2.589 miles. So you can see how, you can
Mhm.
visualize, guys, the size and the amount.
Mhm. Yeah.
The
I mean,
the
it's going
mean.
down.
Right. I
There's
mean,
nothing to say.
and that's always, I know there really isn't. It's like every,
It's
graph,
going down.
either something's going up in heat or
Uh,
it's going
and this
down in
is
ice. I mean, it's,
yeah. I
we
mean,
show
what else
these
can
all
you
the
say?
time. But think about think about these numbers. I mean, so much. And then I heard, what was it today? I read the amount of melt water every day is phenomenal.
Oh
Phenomenal.
yeah,
People don't know what's
absolutely.
going on. They're going to squabble about a lot of things, but they don't even realize this is happening. People just don't
Mhm.
understand. There, and
Oh, this
look
is
behind you.
yeah, that's
Beautiful.
the Mendenhall Glacier behind us, and of
Yep.
course that connects to 1,500 square miles of the Juno Ice Field, going across Lake Mendenhall to
Mm-hmm.
catch the Mendenhall River before, it's just like, oh, doopy doopy doo, no problem, everything's groovy. Of course, this lake didn't used to be there; it used to be glacier,
Yeah,
So I mean, this thing is melting fast, and
that's
there's a
incredible.
lot of water being disgorged right now.
What's the green on the top of the mountain
That's like
behind you?
vegetation. That's like trees and stuff.
It's
Yeah,
they
that's
don't.
trees and
So
stuff.
that's trees because from here you
I
can't
guess
tell.
it's kind of hard
Wow,
to say. I don't know.
wow, wow. Oh, this
Okay,
was a good
this
one.
is this is what I want to show you guys. Up and down the Mendenhall River, the entire bank has been pushed back, and all these full-grown trees are just dumping. Thousands of these things are just dumping
Oh
into
my
the
God.
Mendenhall River. Yeah, dumping full
Wow.
trees, and
Are
this river has expanded over the last several years from 30 feet to 150 feet
Yeah.
wide.
Did now are
Yeah.
they are the forest people up there recovering the trees to be used since they're coming down
Well,
anyway? That's a lot of lumber that's coming
yeah,
down.
I'm sure they must be
Yeah.
because this is very valuable stuff. But what is happening is it's causing cloggage in the river and it's making it dangerous for rafting, as I have
Wow.
found. As I
Wow.
found.
Wow, wow, wow.
Yeah. Yeah.
So that's pretty hairy. That's the whole, and the just the
Yeah.
amount of the size that that I visualize that you told me is overwhelming. And it's happening other places. Just this was significant for you. This is a beautiful
Mhm.
picture. This oops.
Yeah.
This blue picture was absolutely gorgeous. I love it
Oh,
with the blue.
I
That's why I
do.
said let's wear blue tonight, Jennifer.
Yeah, we
Yeah,
did. We
blue in
coordinated
honor
our
of your
outfit.
of this picture. I would have
There you
loved to be there. Look at
Yeah,
that. Just
gorgeous.
beautiful. Okay, now we're going to move on to your story.
Okay.
Holy
Right.
shit.
So, because of all the logs that were in the river, they would cause like these cloggages, like a giant beaver dam, because all these logs grouped together. And this poor guy here, he was in the boat, like further, he was ahead of me, and his boat had gotten caught in this clog of trees, and the boat jacked in. And so he jumped onto the clog of trees to try and free the boat, and then he got stuck on the clog of trees. Then our guide went to try and rescue him across this raging river to see if we could get him because he was basically stranded on this big clog of trees from all the erosion. And so he jumped into our raft and he missed. And I grabbed his hand and then I grabbed his life jacket and we got him into our boat. And then he went
Wow.
into hyperthermia because this river is like freezing, literally, because it's coming directly
Phew.
off that glacier field.
Yeah, and look at the banks. Unbelievable. He's lucky
Yeah,
he didn't
yeah,
get conked on the head.
yeah, yeah. So this is a real life, and this was caused because of the trees all falling into the river, and,
Wow.
and the river being so big.
Wow.
So
Wow, wow. And
yeah,
then we look at the big picture.
yeah.
Global sea
So
ice.
the important thing to note here is things started, and every single person is going to remember this. Remember last June,
Mm-hmm.
not 2 months ago, but a year and two
Yes.
months ago? That's when things really started going off the rails. And you
Yeah.
can see that 2023 line, it's significantly lower. And for a while it looked like 2024 might recover a little bit, but look at it.
Yeah.
Now we're meeting up with the 2023 line, and we're into a different trajectory. This is not 2 standard deviations. This is cutting
Right.
a whole new track.
The deniers want to I don't know what else to call them. They're using, see where the pointer is? They're using that point to say, see, it's going up. And then they're cherry picking the data and trying to do that. But then, also this is extent. This is not, it's thin ice. It's baby ice. It's not volume or thickness. It's extent.
Right.
And they don't
Right.
talk about that, oh, this is extent. It might be out there a little farther, but it sure as shit is an old ice.
Yeah.
So
sure.
both poles are now observing unusually low sea ice conditions, and therefore global sea ice extent is yet again near record low
And this
levels for the current date.
And this is composite. This is global.
Yep,
So
all of
it's
it.
taking Antarctica, it's
Yep.
taking the Arctic, everything. It's all together.
The whole world, guys. It's all the whole world.
Mhm.
Now we're going to go back in time.
So some of you history buffs out there might know that the Klondike Gold Rush in 1898 was a pivotal event, and there was a gold rush, and people thought it was going to happen again like it happened in California just,
Yeah.
40 years before,
Right.
so they all went along, and one of the people that went along was my Uncle Tom.
That is
who
so
here.
cool. That is so
Yeah.
cool. I love
That's
it.
my great uncle Tom. He's on. Yay, great Uncle Tom. So he thought he was a good San Francisco boy. I come from a San Francisco family. And he thought he would try his luck in the Klondike Gold Rush. And so he went along, and I have his diary, believe it or not. This is
That's so
Uncle
cool.
Tom's diary of this event.
That's
of the
really
Klondike Gold
something.
Rush.
That has
Yeah,
got
it
to be
is.
quite a story to read.
It is.
When
It
did you
is.
first
Quite a
read? When did you first get it?
Well, everybody in our family, Uncle Tom's diary. My dad actually transcribed it from the
That-
Leatherette journal that he
Really?
kept it in. But he kept this journal
That's so cool.
when he went on the Klondike Gold Rush.
Yeah.
And it's a day-by-day journal of what he did, his challenges, and all the things that happened. And he was gone for 7 months, all told, trying to make his fortune. And
That
he
is
was
so
just,
cool, Jen. I love this
yeah, he
story.
was just lucky to get out alive.
Yeah. Awesome. Well, this right here is what?
Yeah, this is so in Skagway. This is where the Klondike Gold Rush kind of started. You would put into Skagway. You go up a fjord.
Yeah.
There's a tiny little town called Skagway. Get up and start hiking, and you can go a couple of different ways, but both ways went over some really steep passes in Alaska, and
Back in the
the
day.
Chilkoot Pass, you had to bring a ton of goods. So everybody had to carry 2,000 pounds because the law was, and I guess it was owned by the United States at that time. The law was they didn't want to have like all these thousands of people going out there and starving to death,
Yeah,
So everybody
yeah.
had to bring 2,000 pounds of supplies and food, and they had to bring a boat. I mean, it was crazy, But my great Uncle Tom went on this Klondike Gold
That's so
Rush,
cool.
and Skagway is one of these little Alaska towns. So this was in the Skagway Museum. I took a couple shots.
Nice.
So, yeah.
Nice. Nice that
And
you
Jack
got to do
Jack
that.
London went on the Klondike Gold Rush, and it kind of created his, who he became later with all his great Arctic novels.
Absolutely.
So, yeah,
Chief Isaac,
yeah.
who was a Tlingit entrepreneur through his exchange stampeders who want help carrying supplies up the what is it? I can't see it.
The
It's so small.
Chilkoot Pass.
Okay. They could hire the Tlingit and Tagish packers. So
Yeah.
that was, there's a
And-
lot of
and he
interesting
talks
history.
about- He talks about it in
Yeah.
this
Look.
diary. He talks about hiring the Indian
So
scouts. So
cool.
he knew all these people, more or less,
So cool. And
Yeah.
Molly Brackett, she was a resident, she was a photographer. Oh, look at
Ah,
that. So she was photographing everything. Tappan
yeah.
Adney, this person was a journalist, Harper's Weekly and London Chronicle, and went up there to cover it. And Emily Craig, a 9-year-old traveler from Denver, Colorado. Beverly, yep.
Yay!
She braved the steep I can't see it.
Chilkoot.
Chilkoot Trail
Chilkoot.
with her
Yeah.
parents and Aunt Lulu, and they find time to celebrate her birthday. So wow, they took her. Look at that. They
Yeah.
took her on
No,
a
it's
trip.
amazing.
That's so
I mean, the
cool.
character of these people is unbelievable. So this Chilkoot Pass, if you go to the next slide, the freaking oh no, that's something else. These are
Oh, I don't think I have the other one. Do I
Oh,
have
you don't?
another? This one,
Probably not.
this
No,
one, and this
it's the
one.
picture of like going up this ice mountain and this
Oh,
line of people, and he writes about this because he had to
oh,
get
why
his
didn't I have it?
2,000 pounds of supplies over this pass, and it was
I'm sorry.
ice stairs that were carved out, and there was a rope on one side, and you would go up like a file of people, endless.
Endless.
So yeah,
And these guys were just there. They were with their dogs. They almost
yeah,
looked military, but I guess that was like,
yeah.
the
Maybe they are.
well,
Who knows?
or the
We
shirt
don't
of
really
the
know.
day.
Yeah,
Wow.
we don't really know.
Wow. I love the
Uh,
history. I think it's fascinating. Okay,
yeah.
and we
All
just
right,
go
then.
and come back to now.
That's right. Well, guys, the Arctic sea ice is thinning. You can see this picture here is that 1994, Sandy? And then going all the
Yeah.
way up
80,
to
84,
2020,
93. Yeah, 94.
84, 1980, 1994 or 84. I can't
80,
see it very
80, I know, 84 and all the way to 2023. Look at the difference in
Okay.
there. Oh
Well,
my
you know
God, the
what?
thickness.
Look at this thing. And this is our beloved Zach Labe. Do we
Wonder if
worship this man?
Yeah, he
Yes,
does
we
a
do
good
worship
job,
this
although I
man.
have to make it smaller to make it look halfway decent. Sort of.
No, we
You
can't see it.
can't?
But
Oh.
it's
It's
better
not a,
big.
it was never clear. I should have made it
No, it
clearer.
wasn't. That's okay. But look, guys, the important thing to understand, the volume is the key factor, as
Yeah.
everybody here knows. And it's like a light is going out. The volume is going away in the Arctic sea ice. Check it out over time. Yeah.
Ooh, yeah, it's very thin. That's why I laugh when they make a big deal out of extent when it's just bullshit, thin, new,
Mm,
what, not even multi-year ice, most of it.
yeah.
If it's growing out, it's not. All right, and tell us about this.
Yeah. So this, I took a narrow gauge railway in Skagway over to the White Pass, and this is the border between Canada and the US right there as we go by. Isn't that cute? There's a little log cabin there. It's just
Look at
like
that.
old-timey stuff, I
Yeah.
tell you.
Old
Very
time.
old-timey.
Oh, I need a song. I needed some
Yeah.
old time music. And there she
Yeah.
is.
No, it's Mary, my friend. So this is in Icy Strait Point. That used to be a salmon cannery. Vegans among you, this is a rubber fish, and all of these are rubber fish. It's
That
really
is
to
amazing.
show how the old salmon cannery looked. So this is an
Wow.
example of the old salmon cannery. I mean, it was they had
It's all
everything there,
theater.
pack them in cans, and
Yeah.
cook
That's
them and send them on out from Icy Strait Point king salmon.
it's
Yeah,
all and that's all just theater.
just theater.
Wow. That's
Yeah.
cool.
And this is the back of the salmon cannery. You kind of get the flavor of how it was. Kind of amazing, little piece of history right here.
Yeah, well, are there any salmon left, Jennifer?
I don't
I
know.
know they're
Oh,
they're
the
farming
bear,
them.
the bear was eating them.
Yeah,
I know.
good.
Be-
If that's who should be eating the wild salmon.
Yeah. And this is the salmon guillotine.
This is real. This is not
These
real.
are
This
these
is
are
still
rubber
part of
fish.
the. Oh my
Everything.
God!
This
It's
is
all
all
just a
this is all,
facility. It's
yeah.
a museum.
Yeah, this is
Holy
just all
crap!
to show you how it looked. This is all
Right.
the original equipment, but these are rubber fish.
Wow. I wonder if this place is used for movies.
It could be, huh?
It could
Tell you
be.
what.
It could
Yeah.
be. Wow. All right.
Yeah.
Well, I think this was a really good presentation. I had a lot of fun. I did.
Yeah.
I really did. I had a lot of fun putting it together. And now we've got a lot of information,
Oh,
and we're not
yeah.
even going to take a break. We're not going to take a break. We're going to go
No
right
way.
through. We're going to talk about the science now, what's
Yeah.
happening, the nitty gritty. And then after we finish our presentation here, we're going to talk to you guys. So stick
That's
around.
right.
All right,
That's
Jen,
right.
go for it because
Yeah.
you
All
haven't been
right.
here in a while. You're reading.
I haven't been here, and I'm so happy to be here tonight.
Me too. Me too.
Guys,
All right.
guys. Okay, this is just out in the Smithsonian Magazine, and it's what we've just been talking about. Alaska's Juno Ice Field is melting at an incredibly worrying 50,000 gallons per second, researchers find. Between 2010 and 2020, the ice field lost 1.4 cubic miles of ice each year, according to a new study. The Juno Ice Field, which extends for some 1,500 square miles from northwest British Columbia, Canada, into southeast Alaska, is composed of more than 1,000 glaciers, and it has been for millennia. But now, perhaps more than ever, the landscape's longevity is in question. New study published Tuesday in the journal Nature Communications highlights the ice field's unprecedented and accelerating melting. Its snow-covered area is shrinking 4.6 times faster than it was prior to the 1980s, researchers say. And between 2010 and 2020, it lost roughly 1.4 cubic miles of ice each.
Jesus.
Now, water is flowing from the ice field at 50,000 gallons per second, reports Seth Bornstein of the Associated Press. Mid human caused climate change, driven largely by carbon dioxide emissions from burning fossil fuels, the Arctic is warming nearly 4 times faster than anywhere in the world. Alaska itself has seen the average temperatures increase 2.6 degrees Fahrenheit since 1980.
Wow.
If we reduce carbon, then we have more hope of retaining these wonderful ice masses. Bethan Davies, a glaciologist at Newcastle University and lead author of the study, tells the New York Times' Raymond Zhang, the more carbon we put in, the more we risk irreversible, complete removal of them. Prior to the 18th century, Earth had seen a period of global cooling and glacial formation known as the Little Ice Age.
Yeah.
Since then, 1/4 of the ice field's total volume has melted. The rate of this melting has rapidly increased in recent years, a trend that is incredibly worrying, Davies says in a statement from Newcastle University. Between 1948 and 2005, only 4 glaciers on the ice field melted completely. But between 2005 and 2019, another 64 melted away, including the Antler Glacier, reports
that.
which once stretched 3.5 miles long.
I remember that.
Yeah. This acceleration might be aided by a few feedback loops in which melting leads to more melting. Thinner ice, for example, warms more easily. Dark-colored rocks revealed by melting glaciers can retain more heat than white snow does, prompting even more snow to liquefy. The feedback processes sets in motion is likely to prevent future glacier regrowth, potentially pushing glaciers beyond a tipping point into irreversible recession, Davies said in a statement. And
All right,
check
now look
this
at this.
glacier mount
Man.
out. So it is like so sad. Like if you look in 1948, there are 1,118 glaciers. And then if you look in 2019, there's only 1,050. So these things are melting and melting quickly and melting more quickly. Also, pay attention to these blue things, ice-dammed lakes. These things can give way suddenly and cause huge flooding downstream.
All
So
these different places.
this is the Juno Ice Field, and it is
Ice
1,500
dammed
square
lake.
mile. Yeah,
Wow. Wow.
yeah,
Look at that.
totally.
Mm.
To complete their study of how Icefield is changing, the team analyzed historical and contemporary aerial photographs, past records of glaciers, satellite imagery, and geomorphological mapping. Putting together this archive of photographs collected 70 to 50 years ago was a little like doing the world's hardest jigsaw puzzle. Robert McNabb, an environmental scientist at Ulster University in Northern Ireland and co-author of the study, says in a statement. But the quality of imagery meant we were able to reconstruct the ice field elevation in the pre-satellite era for the first time. So they're seeing things based on this,
Yeah.
composite of information that they've never been able to see before. Look at
Look at
this
this.
freaking thing with
Look at
these
this.
crevasses. Holy
Yeah.
crap.
Near northern
Right?
British Columbia, which is also on fire.
Yeah.
Oh,
there you
there's a
go.
lot of fires, Jennifer. The whole
Oh,
West
yeah.
is on fire. Russia's
Oh, yeah.
Siberia's on fire.
Yeah.
They're evacuating in California and Idaho. It's just crazy.
Yeah. No,
All
it's
right,
horrible.
let's get back to
Horrible.
the Arctic.
Some of the differences
cool.
revealed in the research are also visible to the naked eye. Maury Pelto, an environmental scientist at New Nicholas College and co-author of the study, first arrived on the ice field more than 4 decades ago as a competitive skier. So this
Okay.
person has been doing this for a long time. In 1981, it wasn't too hard to get off on and off the glaciers. Pelto tells the Associated Press. You could just hike up and you could ski to the bottom or hike right off these glaciers. Now, however, lakes have formed on the edges of the glaciers from melting snow, and new crevasses could pose hazards to skiers. Yeah, I would say so. You
Yeah,
don't even
it's
want
the
to fall
same
into
thing
that
in
thing.
it's also
Jesus.
the same thing in Argentina.
Yeah, no
They're
kidding.
having heat waves down there.
Right. Between 1770 and 2019, every single glacier in the ice field receded, the team found, giving rise to at least 50 new lakes. Research published last year in the journal Science projects that even if global temperature rise is kept below 1.5 degrees Celsius warming threshold compared to pre-industrial temperatures, roughly 104,000 glaciers, or about half the world's total, could disappear by the end of the century. And there you have it, up close and personal, guys.
Thank
I
you,
saw it for
Christian
my own self.
Thorsberg, the writer. Christian Thorsberg.
Absolutely.
All right.
Absolutely.
Now it's similar. Are we going to read this whole thing?
I don't know, Sandy.
Let
It
me
might
look
be a
at
bit
it.
of overkill.
Well, what I'm
Yeah,
going to do is just say, okay, there's a lot of journalists reporting right now on Juno.
it's important to
And
know that
yeah, it's
everyone is talking
yeah,
about Juno and the
somebody is.
Mendenhall Glacier
This was
and
July
the Juno
2nd.
Ice Field. Yeah,
Absolutely, because
yeah,
people are interested. And as I was doing the research for
yeah.
this show, there were some videos out there that got, 200,000 to whatever
Wow.
views. So some people, yeah, they might not be watching us, but they're certainly watching something. And
hmm
so again, it's the same information. This was a tweet. Loss of snow and ice on Juno Ice Field in Alaska is accelerating. This is driven by a number of feedbacks that accelerate melt. So this was Beth Ann Davies, and
hmm
she had her graphics were up. Let me see if I can
hmm
play around with them. I don't know. It might be too. Yeah, loss. If we could see this one, this is pretty
Oh,
cool.
yeah, that looks
Look at
pretty
this.
good. Yeah.
It shows you the different parts,
It
and
shows you the
yeah,
flow, like there's
right.
different parts of
Uh,
this Juno ice field, and
yeah,
they all kind of loop around the mountains. And then
yeah,
when they reunite, they basically make these big licorice lines, and that's like usually a couple of different parts of the glacier coming together, and it tears up a whole bunch of rocks. So the nature of these glaciers is they have these long, streaky dirt lines.
this is a good. I like this well, is this a Venn
Yeah,
diagram? What is
it's
it?
all.
Yeah.
Oh yeah,
It's cool. Yeah, I know. But
I
the
know.
forcing. All right, but there's a lot out there if you
Yeah,
know where to look.
it
If
is.
you know where to
Yeah.
look, and she had quite a bit on here. So, oh
Oh
wait,
yeah.
this just came up. Daniel Swain. All right, we're not doing fires, but see, he's showing
But
everything's
it's
on fire.
happening.
Yeah, it's
It's freaking
happening.
happening.
Yeah,
Yeah,
it's
it's
freaking
freaking
happening.
happening.
All right, so we'll go back to this one really quick and just go down that they are talking about they're flat. Plateau ice fields are particularly vulnerable to accelerated melt as the climate warms since ice loss happens across the whole surface, meaning a much greater area is affected. Additionally, flatter ice caps and ice fields cannot retreat to higher elevations and find a new equilibrium. So there's a lot going on, and but see, the Associated Press is asking, and Reuters is asking. They're
Hmm.
asking, and as we saw, 64 of them have disappeared. And that's between 2005 and 2019, the study said. I mean, really, guys, that's friends of ours out there in social media land. This is
Hmm.
seriously big shit. And just like my show on Tuesday, I'm like, serious? The heat and now the glaciers, it's big stuff. And what we
Big
wanted to
stuff
do
is
here was show
everywhere.
you, yeah, it's everywhere, but we wanted to show you Alaska, the pictures from the New York Times, because maybe the New York Times sucks, but their pictures are good and they have a good climate desk because they can afford to pay really good climate reporters. So
Hmm.
here we go. This is the Piedmont
Hmm.
terminus Taku Glacier, and that's of more than 1,000. So isn't that cool,
Wow, that's
Jennifer?
beautiful.
I mean, it's
So
breathtaking.
beautiful.
I
It
mean,
is.
it is my bucket list, and I don't know if I'll ever do it. I can't even get the bucket to go out of my driveway. Let's see. I live vicariously through my wonderful Jennifer. Mwah.
Mm,
All right, here we go. Oh, look, this
that's
one. I
beautiful.
love this one. This is the
That's
Taku
gorgeous.
Plateau. Just amazing. These pictures are gorgeous. And it's not
Oh,
AI.
so
They're
gorgeous.
real,
So gorgeous.
not AI. Soon to be not so gorgeous. I mean, you can see here. It's glacially transported boulders and cobbles on ice sculpted bedrock. But this was covered at one time. Well, maybe all the way. Yeah, I think it was. It
Oh
was
yeah, no,
covered. It
these
was all
things were
covered.
covered. I mean, in the last ice age, this was covered all the way to the top, you know.
Hmm.
It wasn't just the valleys.
Just beautiful. Look at, they want me to
Yeah.
reactivate. F you. Okay, let's see.
F you, New York Times.
I'm not in the mood. If they could just give me the climate desk, you know,
Yeah.
yeah, and then they tell you $1 a week, and then you know what happens? Your charge card
All
gets.
of a sudden, ka-ching, ka-ching.
Yeah, we're still, they're the neoliberal capitalist New York Times. All right, here we go. I won't wear my politics tonight. Uh, this this is pretty hairy. Avalanche
Yeah.
Canyon with Gilkey Glacier in the background showing a steeply incised glacier valley. But
Woo.
look at the, it's
Oh
nothing's
yeah.
up there.
Freaking gorgeous.
But it is
Just freaking
gorgeous. It's breathtaking. It's breathtaking. Um, all right, we're gonna go. Okay, those were the pictures, and we're not gonna read the 123
yeah, that
comments
yeah,
because
yeah, yeah.
no, we're moving on because we are
Right.
moving to Greenland, where Going South lives. Who is in the audience? Hello, Going South. He is being amazing tonight because it's ice. All right.
Ah,
Research expedition aims to understand global effects of Greenland's melting ice. And this is part of what in my video the scientist was talking is part of this, I believe it
woo,
was. So Jen, do
woo.
you want to read this one? Or do we
You
want to tell
go
everybody?
ahead.
All right, I'm
Yeah,
going
you
to
go
skip
ahead.
through.
It's not very long.
No, we're going to talk about the researchers that are going to Greenland, and they want to understand, although I think a lot of them already understand, how it affects the climate systems. And that is where, how we always used to say, what happens in the Arctic doesn't stay in the Arctic. And now more than ever is that a true statement. So I think I got to resurrect that meme that we used to have for the channel. The research ship, it's the David Attenborough. It's going up to the Arctic with 40 scientists and a support staff from worldwide research institutes, including British Antarctic Survey, and that's where Dr. Gilbs works, I believe. We've had her on the channel, the Antarctic researcher. And I wonder if she's even going on this. I got to write to her. She's still making videos, so maybe she's going. The Polar Research Vessel will embark on the 6-week mission as part of the Klondike project to study glaciers and life in coastal waters around Greenland, one of the areas on Earth most affected by climate change. I don't know, maybe she wouldn't go to Greenland because she does specialize in Antarctica, but this would be a cool trip. She said Bass said warm Atlantic waters moving through the fjords eventually meet the ice fronts and of the marine terminating glaciers, increasing melting and causing icebergs to break off. In turn, the injection of increased fresh meltwater into the ocean is altering both ocean currents and marine ecosystems around Greenland and farther afield in North Atlantic, with potential effects on UK weather systems. And see, it's all related. And even Greenland, that Donald Trump wanted to buy, is related. Dr. Kelly Hogan, BAS marine geophysicist and project co-lead, said our expedition is extremely timely as we're seeing every day in the news how the Arctic is changing, and we know there will be knock-on effects for the rest of the planet. So they want to tell everybody how to put your helmet on, basically. We need to understand how the Greenland ice sheet is likely to decay over the coming decades and centuries, and what the subsequent effects will be on both ocean currents and marine food webs. That's very important because
It is.
the marine life has to eat, and I think human beings should stop eating the marine life. This is now urgent information for us to gather so policymakers can understand what will happen in the North Atlantic and set out appropriate adaptation and mitigation plans. The team will focus on key sites close to the Kegerlusok Fjord, which I probably did not pronounce right, aiming to determine the intricate processes driving changes to the waters by studying what's happening now and during warm climatic periods in the past, BAS said. It's added that researchers can help anticipate future ice ocean marine ecosystems by extending the modern observational record back through the last 11,700 years, a period known as the Holocene. That is so cool. That research will be interesting. While some records of Holocene iceberg calving and warm water inflows do exist around Greenland, records of how the glaciers then decay and effects on marine productivity over many decades are lacking. Professor Colm O'Cothig, did I say it right, you think? O'Cothig, a glacial and marine geologist from the Department of Geography at Durham University and project co-lead, said understanding the Holocene record of the Greenland ice sheet change and the role of the ocean thereon is crucial for placing current observations of ice and ocean change into their longer term context and for underpinning predictions of future change. The range of tools to be deployed from the RRS Sir David Attenborough during the Klondike cruise provides an unprecedented opportunity to assess this change over the last 11,700 years. So there'll be glaciologists, oceanographers, biologists, I bet there'll be anthropologists even, will collectively use a range of instruments to retrieve the samples from rocks on land and from the ocean and from the seafloor to gain a comprehensive picture of this region and its current and potential future response to environmental change. Using state-of-the-art capabilities, the boat, and deploying advanced underwater robotics such as the Gavia, operated by the Scottish Association for Marine Science, will investigate modern interactions between the meltwater expelled from the glaciers and the inflowing warm ocean waters, as well as how this affects primary productivity in the Greenland fjords and coastal seas. I think this is just really cool.
It's amazing.
Yeah, it's using fossil fuels to do this, but we got to learn. Helicopters will also allow researchers to collect terrestrial rock samples. The marine sediment cores from the seafloor and terrestrial rock samples will reveal how glacier size, ocean temperatures, and carbon storage on the seafloor have changed during the Holocene. So that's how we will know what the hell's happening, Jennifer, right? So this is all
Absolutely.
pretty interesting. So we've talked about, what's happening in Juno, we've talked about glaciers, we've talked about the research. Now we're going to go a little bit more into how
This
Greenland's a
thing
bit screwed. And I don't want to use, yeah,
crazy.
do I want to use the F word? And we have somebody in
No,
our chat that lives in Greenland. So,
no.
all right, go ahead.
All right, let's go ahead, guys. This just, oh no, it didn't just come out. Came out in January, but very, very interesting
Important.
science.
Hmm.
Greenland is losing so much ice that its gravity is
That's
getting weaker.
intense. So if going south in the chat jumps up and down on Greenland, he doesn't come down as fast. All right. I had to make a joke. I'm the only one laughing at.
All right. All right. Greenland is losing 30 million tons of ice every hour, a new study suggests. The Greenland ice cap is losing an average of 30 million tons of floating ice on average per hour, faster than scientists had previously estimated, according to a study published in the Nature Journal. William Colgan, who works as senior researcher with the Geological Survey of Denmark and Greenland, said in a year that's 40% more than all Canada's annual water use. The visuals are quite staggering if you get up there, Colgan told the Current's Matt Galloway. The loss of ice is so great that Greenland's gravity is getting weaker. This is the part that's so amazing.
It's
Greenland is a relatively massive object and it holds permanent tide of water close to it. So Greenland, with all its gravity, sucks all this water close to itself. So as Greenland begins to get smaller, its gravity begins to get weaker. And that water it holds tight begins to slosh away to faraway places in the world where gravity
Oh
is
my
not
gosh.
weakening.
So the
Look at this
gravity,
ship.
it can't hold the
Yeah.
water. The gravity, oh my, this is like
The
really
fall
grave. It's
like
a,
the ocean, like the
yeah.
ocean is sucked up against it, and
Wow.
now as Greenland gets less, it's like it's releasing it.
It's a
The
grave situation.
as Colgan notes, the 30 million figure only takes into account the floating ice around the edges of the glacier. If you factor in the entire ice sheet, including below sea level, the total ice loss is around 9 and 10,000 tons a second, he estimates.
Who can even understand that
Yeah, it's
amount
like
of water and where it's going? We know where it's going.
yeah, it's too big to understand. That amount of fresh water is being dumped into the ocean, and it's concerning for some scientists,
Right.
including the study's lead researcher.
It's going
The
right to
changes
Miami.
around, the changes around Greenland are tremendous, and they're happening everywhere. Almost every glacier has retreated over the past few decades, Chad Green, NASA's Jet Propulsion Laboratory, told The Guardian. Dumping fresh water into the North Atlantic Ocean weakens the Atlantic meridional overturning circulation,
Oh, yeah.
a system of ocean currents that circulates water within the Atlantic Ocean, bringing warm water north and cold water south. Green isn't sure exactly how much of it's currently being weakened,
Well, we
however.
just have to ask Steven Romsdorf or Jim Massa. There you go.
There you go. There you
Okay.
go. Noticeable changes. Colgan says most of the global effect of Greenland's mass ice loss is felt in southern hemisphere. On the flip side, when Antarctica loses mass and weakens its gravity,
Oh,
that's when sea level is felt in the northern hemisphere.
oh.
There's still an impact on Canadian water levels, though, but that's felt differently between the coasts due to factors including fluctuating air currents and ocean currents, according to Colgan. He said the sea level rise in Vancouver, for example,
You were there?
is also affected by a phenomenon called subsidence, the sinking of the ground where the earth beneath the surface
Jeez.
shifts either by natural processes or human activity. It's
Man.
going in the wrong direction versus in northern Canada, we have so much uplift that sea levels might actually be falling in relative terms, where the land is rising out of the ocean is sort of falling off this shoreline, right? Colgan says it's tough to tell what impact the meltwater from Greenland will have on species in the ocean depths. There's definitely a handful of studies that suggest more meltwater from more nutrients and more upwelling of fjords where deep cold water rises towards the surface, which will generally be good for productivity or primary productivity of the ocean and help fisheries.
Really?
But there's also some studies, if you get too much of this fresh water, you can start to have freshwater caps, which is
Oh
what Jim
boy.
talks
Uh-huh.
about.
Yeah,
The
because
striation.
yep.
It's the striation, and which reduces
The
the
ver-
vertical overturning. So that's more
in the
likely
water
what's
columns.
happening.
Oh my
Ocean
God.
are also getting more acidic as more carbon dioxide from melted ice water dissolves into them. Colgan says that's generally bad for fisheries productivity. It's hard to tell because the fisheries are also highly manageable human resource. So, looking for the impact of natural processes on the fisheries is pretty challenging. And do you see these, like this picture, Sandy, here?
Mm-hmm.
Like, I'm going to say something. Like,
Look at this.
if you turn your head to the left and look,
Mm-hmm.
it looks like two eyes, a
It
nose, and a
does.
mouth.
It does. It does. It
It
does.
looks like
Look at that.
Munch's scream. Do you know that thing, the scream, where this person's
Yeah.
going?
Yeah. 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 Oh my
That's
God.
what it looks like.
It's the
Totally,
scream.
it looks like the
Yeah.
scream.
Ah! Well, I want to
I
scream
know.
at some of
I
this
know.
data and
I
information.
do.
Instead,
Yeah.
I internalize it sometimes and I just cry.
Oh. Colgan said he'll be back in Greenland in May to work on a big crevasse field, a massive crack in the ice sheet in the central western part of the
So
region.
he
Then
already
again,
was there. We're gonna have
northwest.
to follow up, Jennifer.
Yeah. The crevasses are phenomenally large. They're 20 meters wide and 5 kilometers long and quite bottomless. They weren't
Wow.
there
These
20 years ago.
these.
So we think they're telling us that the ice
Yeah.
sheet is a little more sensitive dynamically to climate change
Oh
than we expected. So
God.
watching this crevasse field evolve year after year is pretty profound indeed.
Thank you,
April.
Mohammed Racini.
Yes, thank you very much, Mohammed Rossini.
Okay. That was
Yeah.
again, we're just going around the world with this.
Crazy, man.
Oh,
Crazy.
now we are going to Antarctica.
You want to do this one, Sandy?
I sure will.
Yeah.
Okay, look at that beautiful picture. Boy, some of these
Woo.
people just make it, and that was taken on the 24th. That's what it
Yeah.
said. And I think, unless it was just, why would they put that date right by the picture if it's the article?
I don't know, man.
I don't know, but it's a gorgeous picture.
It's
Stability
very
of
pretty.
Antarctica is threatened by submarine canyons. Now that's different. In the silent depths between the Antarctic ice sheet, submarine canyons are silently playing a massive part in the ice sheet's instability. A captivating new study casts these underwater formations in the role of critical conduits, channeling relatively warm circumpolar deep water up from yawning abysmal depths to the continental shelf. This warmer water then trails to the base of the ice sheet, contributing to its slow but steady melting. Submarine canyons and Antarctic glaciers. The extensive research led by the National Institute of Oceanography and Applied Geophysics, includes experts from the University of Southampton, shines a spotlight on sedimentary bodies within these canyon systems. These bodies bear the geological traces of persistent bottom currents coursing along the canyons, carrying the ocean's heat like a silent, creepy courier to the Antarctic landmass. The intrusion of relatively warm water onto the continental shelf is widely recognized as a threat to the Antarctic ice sheet. said a study lead author, Frederica Donda, a marine geologist in the OGS Geophysics Department. Our endeavor to constrain the extent and long-term persistence of this phenomenon is crucial in deciphering potential responses to ice sheet of the ice sheet to global warming. So the Totten and the Hynes glaciers, the team's dedication drew them to Totten and Hynes glaciers, the gatekeepers to the two most significant subglacial features in East Antarctica, Aurora Sabrina and Wilkes subglacial basins. A gold mine of discovery awaited the team. Their rigorous analysis unearthed dome-shaped sedimentary bodies or sediment drifts spanning several thousand meters wide and measuring 40 to 80 meters thick. The properties of these bodies strongly suggest they were sculpted by bottom currents streaming upwards towards the continental shelf. Wow. Can you visualize that? Water through the submarine canyons. Recent data collected from one of the canyons flowing off Totten Glacier reported currents of about 10, I think it is, I don't
centimeters.
know. Is it 10
Square?
centimeters square? I don't know I don't know the measurement for currents. Forgive me.
right.
Near the seafloor, and usually I take it and I write it in, but I didn't. A startling discovery at a depth of 3,500 meters. The current is a part of oceanic circulation characterized by large cyclonic eddies. We learned all about eddies with Jim, transporting different water masses, including the warm waters of the circumpolar deep water. A portion of these eddies find their way southward through these canyons, paving easy routes to transport those warmer masses towards the continent. So this thickness of the sedimentary bodies identified within the canyons, it's an indirect testament to the continuation of oceanic heat transfer for at least the past 1 million years, noted Donda. The thickness of the sedimentary bodies identified, sorry, I read that already, noted Donda, melting of the East Antarctic glaciers. So up until a few years ago, we thought the East Antarctic ice sheet was stable. But the evidence today just doesn't reveal, it doesn't just reveal that some East Arctic glaciers are melting, said Dr. A. Silviano from the University of Southampton. We have crucial new insights that there are preferred pathways for warm waters to constantly reach two of the largest glaciers on Earth and melt them from below. And this is what I've been watching other videos on this, and it's pretty hairy, melting them from below. And Jim has told us all about how the warm water is underneath. The East Antarctic ice sheet has recently started piquing the interest of the scientific world because even a partial melting of this ice giant could drive a significant rise in sea level. So we're getting it from the north, the south, I mean, from everywhere. To put this in perspective, the Aurora, Sabrina, and Wilkes subglacial basins alone bear the equivalent of over 8 meters of global mean sea level rise. So the implications, the repercussions of these findings, they stretch far beyond the icy realms of Antarctica. As the warmer water continues its journey beneath the ice, the gradual melting of those glaciers poses a looming threat to global sea levels. Scientists are increasingly concerned that even a moderate increase in melting could displace millions of people in coastal regions worldwide. It's happening already. Understanding the dynamics of submarine canyons and their influence on ice sheet stability is vital for modeling future sea level scenarios and preparing for inevitable environmental changes. So the next steps in research will be ongoing exploration of the Antarctic submarine canyons, advocating for further studies that will enhance our understandings of the region's complex interactions between the ocean and the ice sheet, implementing advanced technologies such as autonomous underwater vehicles with high-resolution sonar mapping, which will allow the researchers to gather more precise data on ocean currents and temperature variations. By unveiling more about these critical areas, scientists hope to develop strategies to mitigate the impacts of climate change and better predict the future of Earth's ice covered regions. So, the findings of the research elevate submarine canyons to a key position to understand the mechanisms tied to the ice sheets melting, both in the past and the present. Consequently, this understanding boosts our ability to predict future sea level rise. So
Wow.
this was originally in Nature Communications. That was pretty
Yeah.
good, actually. It was really
Yeah.
comprehensive, and
Yeah.
I think that this article did a good job explaining exactly what's happening. But this really quickly, I wanted to move because this was done in February. Melting of Greenland ice. We're going back a little bit to Greenland because they predicted this. Melting of Greenland ice could cause European heat extremes. Now, what have we seen? I did the show on Tuesday on heat. So everything is connected.
Hmm.
Everything is connected.
So
And
this one was published when in February? Is that
yep,
what it says
yep,
there? So look at that, guys. It's a prediction. They said all this stuff melting in Greenland is going to cause extreme hot weather in Europe. And guess what? Sandy
could
showed
be.
that on
Yeah,
her last
right.
show.
Yep.
Yeah,
Could be
Spain
worsening. I mean,
and
it's not necessarily totally cause and
oh,
effect,
it's
but it's a big
related.
part of it. Heck yeah, it is.
Related.
So we just wanted to show that. And then we have this one, which is similar. It's just warm water is sneaking underneath the thwaites. These incursions driven by the tides could amplify the retreat of ice. So I don't know
Mhm.
if we want to do this whole thing, but I thought I'd go down.
Well, I think
You want to
I
do
think
this?
it's still pretty
You want
fascinating
to do this one?
to talk about the glacier underbelly. Do you see the
All
glacier
right.
underbelly?
Yeah, that
The
was
Thwaites
this one.
Glacier,
Yeah, this is
and
the one.
it's really important to
Yes.
understand the vastness. I kind of feel inspired just to let me get started with this and see how I feel. Okay.
Okay, yeah.
In Antarctica, the warm ocean is stealthily attacking a major glacier through previously unknown route, undermining its foundation on a daily basis. As each rising tide lifts the coastal terminus of the southern continent's Thwaites Glacier a tiny bit off the sea floor, a warm, salty
Mm,
water squeezes in underneath, satellite measurements reveal. This inrush of seawater forces its way many kilometers inland as it melts the ice from beneath. The meltwater and seawater are then flushed back out as the tide falls. So this is like this thing that just keeps going back and forth and back and forth. And what is so important to understand is how huge the Thwaites Glacier is. I mean, there's
huge.
a scientist called Eric Rigneau. Maybe you
Mm-hmm.
guys
Oh,
know of
yeah.
him at the University of California in Irvine. For 2 decades, Rigneau had used sporadic satellite radar measurements to monitor Thwaites' grounding line, which is currently retreating roughly half a kilometer per year. But in 2023, he and his colleagues used a new set of satellites called ICEY or ICEYE to capture these measurements 3 times a day.
Oh
Those
my
more
goodness.
frequent measurements revealed some very big surprises. We
Mm-hmm.
see dynamic events that we've never seen before. At each high tide, a thin layer of seawater 10 to 20, 70 centimeters thick pushed under the edge of the ice sheet and migrated 6 to 12 kilometers inland. The researchers could detect this because the satellite radar showed the top of the surface of the ice rising and falling as the water moved beneath it. Across the entire glacier, that amounts to 200 million cubic meters of seawater rushing in and out each day, about 400 times the volume of the world's largest type of oil tanker. This is
Mm.
just fascinating. So basically, the Thwaites Glacier is being loosened like a tooth, and it's just like choo, 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 and it's just really important to understand that this tidal intrusion is a phenomena we
Mm.
haven't known to look for. It's suspect it's very widespread. So they are very interested to see how this will affect the retreat rates. So that's pretty fascinating, guys.
It
Really
is.
pretty
And it wasn't that
fascinating.
long. I didn't realize that this one
Yeah, and
was
it
so
was
interesting.
slightly different. It was
But
slightly
it's
different too.
totally interesting. And we've covered Rigno before. Or I mean
Yeah,
I'm sure
absolutely.
we have. We've done this for
Hmm.
so long. I know we have, and I've followed
Uh-huh. Yeah.
his work. So it is fascinating. Well,
Yeah.
let me tell you.
I'm
Go
I'm
ahead.
ready for this last one.
All right. All right, we're gonna move on. We what we are is a little bit different, and this is a good old friend, George Sacralitis.
Yeah,
Je-
George Sacralides, and this is a great blog post he just published.
yep,
Why become an activist when the world is already collapsing?
strap in.
How much time do I have left? This is the very first question which pops into a terminal patient's head when they first hear of their diagnosis. They simply want to know how much life they have left, down to the number of days, if possible. Every single day remaining has now gained a new significance, new value. There is no time for regrets, literally. They need to wrap up their unfinished business, say their goodbyes to loved ones, contemplate, look back on their lives, spend hours staring at the sea, find peace, and say their own goodbye to a world that they will never see again. Say goodbye to existence. Our civilization is a terminal patient who refuses to have any of the self reflections that a typical terminal patient would have. It is a self destructive chain smoker continuing to smoke as cancer metastasizes all over their body. This patient is ignorant of their own existence, of time, space, and of the existence of the children they are leaving behind in this collapsing world. This patient is unable to even ask the question, how much time do I have left? They don't want to know the answer. But the metaphor of patient versus disease versus existence is incomplete because when a patient dies, the world remains. In this case, the world is collapsing along with the patient. This civilization may be leaving this world, but the world is leaving us as well. Even if humans had the choice to come back to this world one day, it wouldn't be here
Mm.
because we are taking with us to our toxic cemetery a very big proportion of Earth's 10 million species, along with the planet's weather machinery. The state of the planet that we leave behind is highly questionable and left to anyone's imagination. What is happening here is much bigger than a terminal disease. The patient, the doctor, the hospital, and what is outside the hospital will all be gone, or at least replaced by an uninhabitable, mostly unrecognizable version of the current world. So, my advice is surrender to the collapse, but do not give up on existence. Like a patient who knows that every moment left still counts for something. An alternative question to the myopic, lazy question of how much time do I have left could be how much can we preserve or even repair? How much can we delay the onset of this disease? And how do we make the best of our time that we have left? For many victims of the climate crisis and the necro-capitalistic overshoot who have already paid the price, it is too late. For the children, the next generation, a shockingly reduced life expectancy is a certainty. We owe it to both those who have already departed and those who will pay for the excesses of civilization to stop thinking about how many more years, days, and seconds we have left and start focusing on what we can do right now.
Mm.
We owe it to the planet. My other advice is stop preparing. Stop hoarding stuff for the impending apocalypse because it won't help you. We live in organized societies, so unless you manage to isolate yourself completely and sustainably at your own risk, it is most certain that you will become a target for attack if you are perceived as privileged. Why, while preparations may give you the illusion that you have achieved some level of peace of mind, in reality, you have made yourself a target. The more you plan, the more you will feel inadequate in a new world which will be largely devoid of healthcare, reliable food supply, clean water, electricity, most of all, compassion and understanding from the people whose country you have emigrated to because yours was either too hot, too fascist, or too nuked by another nation to continue to live in. The more you panic right now, the more you are forgetting that we are all in this
In this
together
together.
and that our strength lies not in individualistic preparations, but collective resilience.
It is. And there you have it. That was George Sacralitis. Uh-huh. I mean, when you think about it, he makes a lot of good points. He really
Yeah.
does. He's telling us that we that the preppers, maybe the preppers have it wrong. Maybe they do. I don't know what anybody thinks in the chat of that, but let's go through a couple of questions. Jennifer, thank you for reading that one. Uh,
No.
let's
Yeah.
just see what everybody has to say, and then we're going to say goodnight. And we hope that you got a lot out of this. Um, I don't know if I've even seen any cues. I don't know. It's you know what? I didn't hang on to the chat. I didn't see the
You
chat
know
at
what?
all.
I think it's fine, Sandy.
Yeah, I'm just going to
Yeah.
have to say thank you to all you guys. You were just wonderful. And it was great to have Jennifer come back. I loved it. I loved it.
It was great to be here tonight. Thank you.
Yeah. I mean, the information that we're learning is always sad and distressful and hard, but we're learning it together.
Hmm.
And we're learning it together, and we have, each other. We have our lives to live, and don't ever give up. Do something. Keep going, like George says, and don't hoard the toilet paper. That's basically how I think that's it, right?
Yeah, totally.
Yeah. All
Well,
right.
guys, it's been a great show tonight. Thank you so much and see you around and stay cool.
Everybody missed you. Everybody
Oh.
missed you. Yeah. All right, guys. Peace out. Peace is big thing. Woo.